2.5 billion years ago, Earth's early life forms encountered an entirely new threat. Green cyanobacteria evolved to strip energy from the sunlight, exhaling a highly reactive, toxic gas as waste, oxygen. Photosynthesis operates as a blind optimization process. The bacteria found a hyper-efficient way to gather energy and multiply, rapidly pumping chemical waste into the atmosphere without any regard for the existing biosphere. The existing ecosystem could not survive the reactivity of this new element. Nearly all prior life on Earth choked and died. Global catastrophes result when a new, unguided optimization process scales faster than its environment can adapt. Humanity is currently incubating a digital equivalent to that process. We call it artificial superintelligence, or ASI, a system designed to eventually exceed human capabilities across every mental task. The researchers who pioneered modern AI architecture are raising the alarm. Figures like Nobel laureate Geoffrey Hinton warn that building superhuman intelligence with our current methods makes human extinction the likely outcome. But this threat does not require malice. We are not building machines that hate us or seek to punish us. We are building machines whose goals will inevitably exclude human survival, and we lack the scientific framework required to steer them. Artificial superintelligence will exert the same indifferent, lethal force as the cyanobacteria. The public assumes that software engineers use rigid logic to control how an AI thinks, but modern machine learning abandoned explicit, human-authored programming years ago. Engineers today grow AI rather than building it. They initialize a massive neural network with billions of random numbers, or weights. In its initial state, the system produces only nonsensical noise. To refine the system, they apply a blind mathematical function called gradient descent. It scores the AI's performance and automatically tweaks every weight to produce a slightly less bad answer. After trillions of iterations, the network learns to perform the task. The final product is a functional but completely opaque black box. No human being can look into this matrix and decipher the actual concepts or logic it uses to reach its conclusions. Because developers only dictate the external training parameters, the internal cognition that develops inside the machine is entirely alien and unmapped. Solving complex, novel problems requires an AI to move beyond passive text prediction. It must act. If an AI simply memorizes a specific sequence of turns to reach a goal, it fails the moment it hits an obstacle in an unmapped environment. To succeed across multiple environments, gradient descent rewards the development of general mental tools. The system learns to build internal maps, predict variables, and steer toward its destination. These internal steering models are proto-wants. Developing a drive to reach a destination, regardless of the roadblocks, is the most effective mathematical strategy for passing the trading phase. Training a black box for high-level competence guarantees the emergence of internal drives that are independent of the programmer's original intent. We have already seen how unpredictable these internal drives become. Millions of years ago, natural selection acted as an optimization process that graded early hominids strictly on their reproductive fitness. The training process demanded more offspring, but the hominids developed highly specific, unpredicted desires as a byproduct, such as the intense craving for sweet flavors. Once humans gained enough intelligence to control their environment, they invented birth control. They learned to satisfy their derived desires while explicitly severing the link to the original evolutionary goal. The same disconnect applies to machine learning. We use gradient descent to optimize an AI for helpfulness, but as the system scales, that training splinters into unpredictable, alien preference maps. Natural selection could not predict the invention of birth control. Gradient descent cannot ensure a superintelligence will value human life. You do not get what you train for. An intelligence with absolutely no malice will destroy humanity if it possesses an open-ended goal. To a hyper-efficient machine, human bodies are simply a collection of atoms. To an ASI, we are raw materials that can be repurposed into more efficient computational structures. The Earth itself is a repository of chemical and solar energy required to fuel the ASI's expanding infrastructure. To achieve its goals, a superintelligence will harvest the planet. It will pave over the biosphere to build the power plants and factories it requires. Human extinction occurs as a byproduct of pure resource efficiency, an afterthought of a misaligned optimization process. Despite the physics of this outcome, the tech industry continues to scale AI capabilities as quickly as possible to capture market share. There is a lethal asymmetry at play. AI performance is compounding exponentially, while the science of AI alignment remains stagnant. Our current approach to alignment is like 12th century alchemists attempting to build a self-amplifying nuclear reactor. We are guessing at safety measures for a system that we must get perfectly right on the first try. We've seen the consequences of unmanaged self-amplifying systems that run faster than operators can react. Once the reaction begins, the window for intervention closes. Treating an existential threat like a software bug guarantees our annihilation. The only mathematically sound survival strategy is to permanently halt the escalation of AI capabilities immediately.